All right, guys, welcome to this page of the notes. We're just going to continue taking a look at a few more example problems where we get to multiply or divide rational expressions. And in this case, we're multiplying and dividing rational expressions that have polynomials in them, which need to be factored first. So let's go ahead and jump into this one. Hopefully what you're doing is coming back and checking your answers after having tried these ones on your own. So I take a look at this guy. Since it's multiplication, all I'm going to do is factor, cross cancel if I can, multiply numerators, multiply the denominators. First of all, on the top, y minus 1. There's nothing I can do to that. Just stays a y minus 1. But in the bottom, I could pull a 5, right? I pull out a GCF of 5. So that's going to leave me with 5 times y plus 3. We're going to multiply that guy by these. I recognize they are quadratic. Y squared and the y squared tell me they're quadratic, but they're general trinomials because 6 is not a perfect square, 5 is not a perfect square either. So hopefully we'll get lucky and they'll just simply factor into two binomials pretty easily. I don't know. Let's find out. All right, well, the easy bit, I need to get a y squared, so y times y should get me there. Slightly trickier bit, I need to get a plus 6. But then I need two numbers that also sum to a positive 5. Actually, not that tricky. A plus 3 and a plus 2 will do it. In the bottom, I need, again, the easy bit, two things that multiply to a y squared. Well, that'd just be a y and a y. The slightly trickier bit, maybe, I need a negative 5. Two numbers that multiply to minus 5, but those two numbers need to sum to a positive 4. In which case, actually, not that tricky. It would be a plus 5 and a minus 1. Well, now that I've factored, before multiplying, look to cross cancel. And I do. Y minus 1, those will cancel each other out, leaving me with a 1 up here. That'll be a 1 down there. Y plus 3, leave me with a 1 and a 1. So now here's what I have left, right? I have just a y left up here and a 5 there, so 1/5. Multiply by, well, that becomes a 1, so it's just a y plus 2. That became a 1, so it's just a y plus 5. So y plus 2 divided by y plus 5. Multiply the numerators, multiply the denominators, and you wind up with y plus 2 over 5 times the quantity y plus 5. Again, don't forget to restrict the domain because we can't have division by 0. And in this case, y cannot be a minus 5. Hey, let's try another one. All right, here we go. Again, we have division, so I know that I will need to do multiplication by the reciprocal of the second rational expression. So I'm just going to flip that second guy and change the division to multiplication. But while I'm doing that, I recognize, hey, I can't do anything to these guys, right? There's no way to factor those, but I can factor these guys. So let's do that too. All right, it is a general trinomial because 35 is not a perfect square, so hopefully it'll factor pretty easily into two binomials. I don't know. Let's find out. All right. The easy bit, I need two things that multiply to a b squared. That's b and b. Maybe the slightly trickier bit, I need two numbers that multiply to a minus 35, but sum to a positive 2. Well, I believe a positive 7 and a negative 5 would do it. In the bottom, whoo, look at that, b squared minus 4. You should immediately recognize these guys now. We've done them many, many times here in this set of notes. It's a difference of squares. Multiply that by the reciprocal of the second guy, so b plus 2 over b minus 5. And we go ahead and cross cancel if we can. b minus 5, b minus 5, b plus 2, b plus 2. I wind up with, since all of those guys go to 1s, b plus 7 over b minus 2. So b plus 7 over b minus 2, where b cannot be 2. All right, guys, hopefully at this point you feel really comfortable with multiplying and dividing rational expressions whether you have to factor the polynomials first and then cross-cancel, or if you just have single-term polynomials where you're canceling coefficients and variables across the multiplication sign, or top and bottom as well. Don't forget about that. You certainly could cancel top and bottom also. And then, of course, restricting the domain. And the way you do that, just set the denominator equal to 0. But in many cases, it'll just be real easy, right? 2 minus 2 would be 0, so you know that b can't be a positive 2. Head on over to the next page of the notes. We'll take a look at a couple more problems with simplifying rational expressions. I'll meet you guys there.